Solving quadratic inequations. When we solve these type of equations, being an equation, we solve it exactly the same way as a normal equation. So we factorise first, and when I factorise this, I get x being greater than 0. This will become plus 5 and minus 4. And then we still solve it normally. X minus 4 is greater than 0, or x plus 5 is greater than 0. Therefore, x is greater than 4, or x is less than 5. Remember these, x is greater than negative 5. Remember, it only changes sign when we're multiplying or dividing by a negative number. Now, to write this properly in mathematical terms, we would be writing this. X such that x squared plus x minus 20 being greater than 0 equals x such that x is greater than negative 5 union x such that x is greater than 4. Example 2. Find the values of n for which the equation has one solution. Now, if it's got one solution, that means the discriminant will equal 0 because it's touching the x-axis. So, when we work this out, we've got, remember, the discriminant equals b squared minus 4ac. A here is 3, b here is negative 2m, and c equals 3. So we got b squared negative 2m all squared minus 4 times 3 times 3. So we got 4m squared minus 4 times 3, 36. Now, one solution, discriminant equals 0, therefore we get 4m squared minus 36 equals 0, 4m squared equals 36, m squared equals 9, and m will equal plus and minus 3. No solution. No solution, that means the discriminant has to be less than 0. I've already worked out the discriminant. It's 4m squared minus 36. Put that being less than 0 and solving it, we get 4m squared being less than 36. M squared being less than 9. And when we do this one here, that means we're on our graph. If we were to draw a graph, because we know that this is going to be 3 and negative 3 from previously, anything less than that means it's underneath the graph. So it has to be between these two numbers. So that means we will have negative 3 being less than m being less than 3, because it has to be between the positive 3 and the negative 3. For two distinct solutions, the discriminant has to be greater than 0. Again, I'm going to look at the graph because I already drew this graph. That's 3 there. That's negative 3 there. Anything greater than 0 is this part over here. So anything bigger than x being 3, and anything that's x when x is less than negative 3. So from graph, we get m being greater than 3, and I should write or m being less than negative 3. Example 3 says show that the solutions of this equation 3x squared plus m minus 3x minus m are rational for all rational values. Okay, so let's work out the discriminant, because the discriminant will give it away for us. So the discriminant here, we've got b squared minus 4ac. b is m minus 3, so we've got m minus 3 squared minus 4 times a times c. So when I work this out, I get m minus 3 squared, which is m squared minus 6m plus 9. this becomes a plus 12m. So I've got m squared plus 6m plus 9, and when I factorise for this, I'm going to get m plus 3 all squared. So it doesn't matter what m is, this answer will always be greater than or equal to 0 for all m values, because it's a perfect square. There's your 4J questions.